Happy Thursday, folks. How's everybody doing today?
We've successfully baited Jeff into joining.
I just missed it.
We're happy to have you, Jeff.
It's like a piece of me has been missing since I stopped coming to these calls.
I figured it would be the other way around.
One of those is true.
Had a 50-50 chance, I guess. We don't have a lot on the agenda today, so if folks have other stuff you want to chat about, feel free to throw it on there. Drop in the notes in case it's been too long. I feel like it's time for me to change the background. It was coming up on 70 degrees here today. 70 degrees in freedom units.
Whereabouts you located at?
Not too far outside DC.
Oh, okay.
But I make a point, I keep at least one thermometer in the house on Celsius so I can slowly try to be a little more international with my numbers.
I just Google it every time.
It's really,
Someday it'll stick.
Celsius really isn't all that bad of a scale to work from. I don't know why there's so much hesitation for it. A lot of the numbers there just kind of make sense.
Squishy human brain like that 100 means hot.
I mean, 100 in Celsius means hot too. It's just hotter.
Yeah.
I, I consider Fahrenheit to be human scale.
All right. Well, we're 5 after. If other folks join late, they'll join late. So let's see. I know I was going to typo something there when I was looking back and forth. I had a couple things on the agenda here. Just mentioned we have some open votes. And I think they both passed. So it's right now just an opportunity in case there's anything wrong in there you want to call out. Feel free to raise any concerns you have now or forever hold your peace. Image spec was holding up some folks, so that one got dropped in there just because they want to be able to cut a release without pulling in a bunch of old libraries that we were pulling in before. And then runtime spec, I think they've probably got a few new things going on over there, and they're trying to get 100% maintainer approval so they can just cut the release right now. I have much lower expectations, so I just keep the vote open for a week. That just keeps the job easier. Let's see here. Otherwise, I figured I would mention again the Blake 3 algorithm is still open for vote. And as soon as someone else votes on it, I'll go ahead and throw my vote back on there. But I kept getting knocked off by people that had good points. And again, this is just registering the Blake 3 algorithm. It's not saying implementations must support it. It's just that people may support it. And if they do use this short name for the digest algorithm, that this is the version of Blake 3 they mean. And so I don't think it's going to break anybody by saying we've registered a new algorithm. It's just putting a stamp on it saying this is what it means if someone ever uses it, but not that you have to use it. All right. So those are things that are open for votes. Let's see here. continuing on, we've got one request here for uncompressed layer sizes. They want to keep track of that. And so I figured I kind of threw out there what the community was saying before on this, but I wanted to open up to more discussion, get some more views on it, see what folks thought about whether or not we needed to have the uncompressed descriptor size for this, since it's not in the image config today. Don't all speak at once. I think the one other opinion I saw there was Tianon that put a thumbs up on my comment that said that the direction we've been trying to go, instead of adding an extra field into the descriptor that says, here's the uncompressed size, is to switch from content level compression where you say, here's the media type of my layer, and you put the compression right on that, to doing the transport level encoding and putting it as a content encoding that gets negotiated by clients. And that has a couple of nice features. One is that you no longer have this zip bomb style attack, but also that in the future, if someone wanted to support a different algorithm, bzip or any other compression algorithm, and the registry supported it too, the client and the registry can negotiate that and have that dynamically switch over to that compression algorithm, and it would only apply during the transport.
I was laughing at your comment because back in October of last year, CG Walters and I had almost the same discussion over in a different issue on a different repo, where I was considering Z standard and looking at what it might take to switch to Z standard by default. And the tangential to this conversation answer is a lot of time, but also uncompressed layers is a much more interesting conversation. And he jumped in that conversation to say, yes, I agree. So I thought it was amusing that it came back up in the OCI and you said basically the same thing.
In terms of trying to roll out that level of change, because it's a non-trivial change and the intermediate state can be kind of bad, or you actually push uncompressed layers and you have no compression at all. What do folks in general think about the rollout process and where tools would fall on that? I'm kind of mentally going down the path of clients doing the image pooling would be really good if today they start supporting transport level encode compression, getting that just out of the box. And then similar for registries if they start to support that.
You can have the everybody support that regardless of whether you allow uncompressed layers, right? You can be like, I'm gonna gzip this gzip layer, and then everybody can show like the clients are working and the registries are working, and then later on allow uncompressed layers. I mean, if it seems like something where you don't have to flag day it, you can build it and then later on enable it.
Yeah, I feel like as long as we don't upgrade the build tooling yet, that would work. It is a bit of a chicken and egg problem where until the build tooling updates, people are very slow to upgrade registries and other tools out there in runtimes as well because there's no content to run it against. So trying to solve that chicken and egg issue and convince people that it's worth spending the time to implement this on their side is challenging.
I guess I'm kind of this proposal that you linked though, doesn't it have a similar problem? I mean, unless tooling was updated to actually start setting an uncompressed sized as well on the descriptor, like you also have that chicken and egg problem where no one's really using it. So I'd still rather go down the transport model. At least that doesn't really have downsides, just might take time.
Yeah, I'm guessing that the CG Walters there was saying that we could add this extra field into the descriptor today with build tooling. It wouldn't break anything, and there'll be extra data that somebody could leverage going forward. And so I wouldn't be surprised if they're thinking about some of their own build tooling, their own registries, and their own clients that are running it, and they've got probably full end-to-end, and they just want to make sure they're not breaking anything. But I kind of agree with you, Jeff. I'd much rather take the longer term, bigger goal of getting this in there and solving the bigger problem.
Yeah, 'cause I think just in terms of already looking, I mean, been getting intimately familiar again with the amount of tech debt inside of registries and past experiments that have been around. This seems like one that, yes, it could be a short-term band-aid, but once you roll out transport level compression, this whole thing essentially goes away, but would have to be maintained more or less forever because it was a thing at one time.
Yeah, I think that probably sums up why I'm so hesitant to adopt this at all, because it does definitely feel like one of the short-term hacks. And short-term hacks and a long-term spec are not a good combination. In terms of getting registries out there, we got a few people representing registries. What are your thoughts of supporting transport level compression, basically doing it at the content encoding level, getting that support add to the registry so you're not storing uncompressed blobs and so you're negotiating with clients? Is that something that could be put on your roadmap? Is that something you already support today and don't even care about? Yay, nay, thoughts on that?
I don't know for sure. I guess I don't. I know that I don't think I've seen anything that explicitly allows it or disallows it, at least for Docker Hub. It does all use Go, and so from what I have used with other services, enabling that would not be that difficult. So I think I would, at least for Docker Hub, I would say would probably be in favor of exploring that option. I can't think that it would be all that difficult given the amount of resourcing and tooling there is around enabling that for Go web servers.
Yeah, I think when I did some tests, because I was worried that we were getting double compression at a certain point, and I started looking through, and I don't think the client, it's either the client or the server has the capability, but they don't default enable it or something. I forget which side of that pairing did not default to do it, because I was afraid blobs were getting double compressed just transparently, didn't even realize it was happening.
Actually,
I'm also
since
curious. Go ahead.
I was going to say, actually, since 99% of the polls go through Cloudflare anyway, I'm sure that they are doing that by default. So I don't even know that I would have to do anything.
So that was where I was going to go next, was when you talk about CDNs out there. How well does a CDN handle the large data pools if it's uncompressed data and they need to start doing compression on their side or something along those lines?
The issue was that the backing, like the on disk data is compressed, right? Like, so the thing serving it isn't just saying like let's negotiate compression. It also has to know that it's already compressed, and so it needs to uncompress and recompress with whatever the negotiated compression is if it's different from what it already, right? Like
So it if it's different is the important thing there, because the server could say, look, I'm just going to support gzip and compression. I'm going to store everything in gzip. If a client asks for something that's not that, maybe I've got to do something on the fly, or maybe I reject it. We can work on error codes on that if we need to.
Right, but it's not just like I'm going to upload the uncompressed thing to my generic server, and then they can negotiate compression the usual way. There's like that additional opinionatedness of the on-disk data.
Yeah, the storage is definitely a concern. I'll throw out another concern that I've got specifically on my side, which is the OCI layout and anything that extracts this data onto disk outside of a registry. Because a registry could look at this and kind of flag it and say that we're storing this in a different way than what the actual content is. If we're talking about things like the OCI layout or other exports, imports of images, do we want to put something in there that can allow it to store a compressed layer, but have the descriptor be an uncompressed data descriptor? I'm trying to think of what that would look like, if that might mean that we have a blob that has, in the layout definition there, the blobs are just stored by their hash. So if we looked at GitHub Open Containers image spec, and I pull up the layout file, I'll drop a link here in a second. But if we're looking at that layout, if the individual
You'd need
blobs in that
like
layout, go ahead.
you need like blobs slash algorithm slash hash dot gz or whatever for like I'm storing this blob, and it's not a direct blob. It is like a quasi transport compressed blob.
Yeah, it's
For
basically
whatever the
on disk compression of this descriptor entry of this blob.
You know, that's how Crane did its initial layout. Was it was the SHA, and then it had the actual file extension that defined the format and the compression. But OCI layout right now, it's just the SHA. That's what the file's names. There's no indication of how it was compressed, or even if it is compressed. The only relationship you have there is its descriptor.
Yeah, it's right now the blob points to the actual hash of itself, and the blob would be compressed according to the descriptor, and so we don't have a problem. But if we started storing this uncompressed, we could add a compression type as an extension onto that blob. And then the descriptor stays the same. The thing it points to would just have an extra extension that says, hey, when you're retrieving this blob, you need to decompress it to make it match that hash.
I mean, but that's all just going to be implementation details. I mean, if registries choose to compress it on disk, they can choose to do so in whatever formats they want. I
For
think
a
that you want to
registry,
modify.
yes. For a registry, yes, but I'm looking at the OCI layout, which is outside of a registry, so you don't have that extra layer of API that's abstracting this.
It'd probably be just up to the client implementation on what they decide, what compression algorithm, like, because like when the compression is basically transparent to the file system. When the file system receives the file, it's been uncompressed through the transport. And so when the client then goes to push that back up to a registry, it then has to decide what content negotiation it wants to use, what algorithm it wants to support. So really, you just have to have a well-defined set of compression algorithms that registries and clients will have to support for these types of actions. That'd probably be the only thing you have to do. And it's just up to the client of which ones they decide they want to deal with.
But Brandon's pointing out that the layout is a non-HTTP transport mechanism. Like something
Yeah.
creates a layout, something else consumes the layout. You don't have
No
HTTP
registry in
headers.
between.
Yeah. So
Which
anything that
I'm
you
thinking
handle
we
on
could,
the
we could probably just register a couple of compression extensions in here and say, if you see a .gz, it's gzip compressed. If you see a, a bz or whatever the bzip extension is bzip compressed. And if we register those, we document that inside of the OCI layout definition. That means a couple of different tools could all interact there, but it puts us in a bad intermediate state, which you might have a tool that starts supporting this early and another tool that doesn't know how to read it.
Right. But that's how new stuff works.
I do a
You
lot
just
of
say,
stuff with
like,
OCI. Go ahead.
This is like a v1.2 or whatever layout, and something else is like, oh, I don't do 1.2 yet.
Yeah, I do a bunch of stuff with OCI layouts, so I would imagine that I would put this behind a feature flag on my side that you'd have to turn on to store it with the extra compression. But then otherwise, for all the people running registries, that is completely transparent to the end client. They're not going to see what the registry is doing on the back end. And then it's just up to the registry to decide, does it store these blobs individually compressed? Does it store them uncompressed? Probably not. Does it encode from one compression algorithm to another? Does it store multiple compression algorithms? I think that's going to be up to a registry implementation, but I'm guessing they probably won't store the blob multiple times either. Unless it's a really popular image. I see both Sajay and Harry coming off mute, so I'm waiting for one of you to say something.
I left a couple of comments in the chat. Basically, the concern is what's the cost of doing this on the registry side, right? And we have to account for it. Like, you have large clusters pulling an image, and if you expect a negotiation and a transcoding on the fly, that's a lot of CPU. Or unless we can discuss how to do this on a client-by-client basis. So my concern is, like, you'll need a lot of operators to support this, even if clients request a negotiation in some way. I mean, today there are a lot of AI models that's being downloaded, and imagine if somebody decided to transcode this on the fly for like a large training or something like that. It's pretty expensive.
The transport compression is a negotiation.
Right.
Client says, I will support these, or I want this. And the server says, no, you're getting this one. So you could implement logic on the server side that says, say, if a blob is over 10 gigs, we serve it as is. Or we only serve it in whichever compression we stored it in. So if we stored it with gzip, then we only serve it with gzip so that we don't have to recompress it. The server has more control here than the client does, in other words.
Yeah, I kind of imagine it'll end up being a lot more like the hashing algorithm, where we essentially have a very short list of, common or known or supported compressions that end up being supported by registries.
And similar to that, I'm imagining that pretty much everybody is going to say gzip is one of the supported algorithms.
So which client is actually asking for this feature?
So this is getting pulled out of the discussion from the request to start making descriptors include the uncompressed size. And so what we're looking at is we can add an extra bit of data into the descriptor and, kind of have this little hacky intermediate state with the descriptor. Or we can go the other direction and just start making the descriptor the uncompressed layer and do the compression at the transport level. But then that compression at the transport level doesn't mean that registries aren't storing it compressed already. And it doesn't mean the registry isn't saying, hey, you might want this in either gzip or bzip or whatever compression algorithm is popular this week. But we're only going to return this in gzip. So you said it was one of your support algorithms. That's what you're getting. A lot of this would be completely transparent to the end user, and it would be semi-transparent to the registry. They just kind of move a little bit of logic from one place to another.
Okay, so the follow-up question for me is then, so gzip or bzip, whatever compression algorithm you have things like, there are various parameters, right? So you're aggressively compressing or you're not aggressively compressing and all of that stuff. So unless that is explicit somewhere, how do I even use this information? If you just tell me that
it's up to the sender, whoever is sending the data at that point. So if the client is sending the data on a build, they will decide what level of compression they want and which algorithms they're going to potentially support. And the registry is receiving it, and it says, well, you need to send it in this format. Once it has been pushed, then it's the opposite direction. The registry is going to say, look, I've got this data. This is the compression algorithm I supported. This is what you're getting.
Okay, so my opinion, honest opinion, realistically, zero chance of anyone doing this from the registry side, at least. Opinion again.
And why zero? Say more. That wasn't more.
I have nothing more to say on the topic, yes.
Yeah, the biggest benefit to this solution to say we get a lot of pressure to change to Z standard. That's a big breaking change. If I say I update all of the Docker official images to Z standard today, the number of broken users is going to be high who cannot pull the images successfully anymore. Where if instead I update them all to be uncompressed content completely, no one is broken. Everything continues to work. The failure mode is just more storage and more bandwidth, and that's it. And transport compression is the way to get the benefits of compressed content back.
How much more do your storage costs go up if you change? If Docker decided overnight, all right, we're going to uncompress all of our supported images. How much more? What's the percentage-wise, estimate?
I don't know that anybody's tracking that data today because we don't track the compression ratios on the data. We just store raw data.
Would anybody need to retroactively change what they're storing? It seems problematic to begin with.
My assumption is if a registry starts to support this proactively, not retroactively when clients have already switched over to doing stuff, but if a registry is proactive about this, they're going to make it so that they're storing it compressed. And
Yeah.
they won't see anything.
And they just decompress it on transport. Or no, do nothing on transport. Yeah, they just say this is what it is.
Yeah, and it's easy enough to say, oh, this blob's already compressed. I'm not going to recompress it. I'm just going to store the compressed copy because this must be an older tool.
Yep. But the digest is the uncompressed digest, so you don't have to.
Well, depends on
do a
what the
bunch of
client pushes. If the client is pushing a
Yes.
compressed blob, the digest is still the compressed blob.
Yeah. Yep.
But a registry could decide in that case to also decompress the blob and store the uncompressed content, or just store a reference to that compressed blob with the uncompressed digest.
I don't
But
think
that's
they can.
again, that's registry implementation details that don't matter because this is a backwards compatible change.
If
All
you-
the tools in existence today support uncompressed blobs. It's
If
part
it's
of the
already
spec.
compressed, if it's already compressed, I don't think the registry can decompress it and recompress it and give you a different digest. They've got to give you that same
No.
digest so the client.
Correct. It would have to store it compressed, but it could also keep track of the digest of the uncompressed content so that if later it sees that same digest, it doesn't have to restore it a second time. It can say, oh, I already have that. It's compressed, but decompression is easy.
No. So even if you want to uncompress, right, how do I know what algorithm or parameters were used to compress it in the first place?
So you don't need the parameters, you just need the algorithm. And the algorithm is either going to be negotiated by a header with the content encoding back and forth from the client to the server, or if it's already compressed as per the descriptor, that would be on the case of the registry knowing when the manifest shows up later on that it sees that descriptor listed in the manifest.
Mm. It's a can of worms, guys. I mean, I'm not. I have serious reservations.
After all the push for Blake 3, when you start getting Z standard and some of these other compression algorithms, this is where you draw the line.
Yes.
See, with Blake 3, this even gets better because now you can do a range request over the uncompressed content and validate the content that you receive from that range request through the Blake tree Merkle DAG magic.
Yeah, I mean, one of the big winners I feel like in this one is probably going to be all of the range requests for people pulling chunks of, just-in-time algorithms, eStar GZ, some of the others like that, Sochi. I'm blank on the names here, so I was trying to remember them. They no longer have to keep track of the gzip state. They can just keep track of where in the tar file they need to range request to.
Yep.
I mean, then technically you could store an entire Parquet file as a layer and do range requests on that for a database stored inside of a OCI registry. I think it's what is that DuckDB can do that.
Yeah, isn't that interesting? And again, for registries that don't want to implement this, totally fine. Uncompressed layers are already part of the spec. It will just work. For runtimes that don't want to implement this, totally fine. Uncompressed layers are already part of the spec, so they already have support for this. It will just work. There's no transition cost except storage and bandwidth, which I'm told are both cheap.
I have not been told that, but probably by someone like Jeff.
Really cheap until it's not. Or it's cheap depending on who's paying.
Eventually you add up, a couple thousand here, a couple thousand there, it starts turning into real numbers. All right, I'm going to chew on what this means for the layout and, potentially what spec changes might need to be made for this. Because my goal is to make this no spec changes needed at all, other than just pointing to HTTP specifications and say clients might want to, or clients and servers might want to support these specs. The more I can do that, the happier everybody is. But the
I'll
OCI
just
layout, I
reiterate.
feel.
Yeah, I'll
Sorry,
just
Brian,
reiterate
go
what I
ahead.
put in chat, that like the amount of things that we get at for this at runtime where we don't, if we're not dealing with compressed layers, there's so much you can do. Even crazy things like, oh, let's just mount this file directly. I don't need to decompress it into a snapshot or whatever. I could just mount this tarball and seek through it and do whatever I need to do, or do a range request against the tarball itself and just get the files that you want or whatever. Yeah.
So thinking about this at more like the containerd level where you're dealing with some of that stuff local on disk stuff, would they be interested in having the OCI layout support effectively transport level compression and putting a .gz on the end of the tar file? On the end of a blob, I should say.
I don't see why not. Yeah.
Means whenever you're reading a
But
blob,
I'm
you
one
have
person.
yeah. It just means whenever you're reading one of those blobs out of an OCI layout, you've got to read one of 3 or 4 different file names and see, okay,
Yeah.
does this file exist? Does that file exist? And if it does, when you read it, you need to pull it through some kind of streaming decompress.
Yep. Which containerd already does. Like it already has that stream decompressor
Well,
interface.
we do it for the entire layout. I'm thinking of individual blobs within the layout. But
Yeah,
if you
yeah,
did
it
it for
does
the whole
it.
layout, that would make it even easier. So we already
Yeah,
have that.
so with Containerd, you can register a decompressor for a type, and when the media type or whatever says it's this, and it'll go look for registered decompressors and go through that.
Very good. Anything else people want to say about that one? Or should we jump over to the other one? All right. Yeah, Rom, there's probably gonna be a lot. I'm looking at how much we can implement this at the client level and on the server level before we implement this at the build level. The more we can get support out there on registries and on tools that are pushing and pulling and runtimes and whatnot, the more that can be supported early, the better the transition is going to be. And of course, Sasha's thrown out all kinds of, look at how crazy it is for people today to support this. All right, the other one on the agenda, and we can circle back to this if people want to talk more about it. But the other one on the agenda was whether the head get behavior was correct, incorrect. I'm really curious what registry was doing this, but they're being polite and not naming names. I saw Tianan chimed in on this one that said, hey, if you give a 200 on a head request, you should probably be given a 200 on a get request. That's what the HTTP spec says. And yeah, I agree with that. But I wanted to throw it out there in case people had more ideas on this one.
And if that isn't strong enough, the distribution spec is also pretty clear here that a head request on this endpoint is the way you check whether or not a blob is addressable in a particular repository. And so if that returns a 200 OK, but then fetching the blob doesn't, that's pretty messed up, and that's a buggy registry.
Yeah.
Yeah, because isn't a head request supposed to be a get just with no body? Like, isn't that per the HTTP spec? That's what it's supposed to be.
Yep, it sure is.
That's how Go even implements it. You give it a
And
body, it just
there
ignores
are a
it.
lot of reverse proxy implementations that actually enforce that by upgrading head requests into get requests and then caching the result for both responses. Cloudflare being an extremely notable example that does this.
I'm kind of wondering if someone implemented this as basically a global blob state for head request and a repository local blob state for get request. But that would be really broken.
From the spec perspective, you can't have it both ways. You can
Yeah.
either have all blobs addressable in all repositories or blobs be repository specific, but it has to be consistent on all endpoints. Or you set up a special repository in your namespace that just has all blobs. You have to do something else. You can't just key this off of the request method.
Yeah, I would just qualify a little bit more that the person who originally filed it is, I don't know if he's accounting for deletes that are happening in between. So there could be retention policy, there could be garbage collection, there could be a bunch of things that could happen in between that's deleting the blob, right? So you make it a head, and then before you did the get, something happened. So if nothing of that sort has happened, and then this is the behavior, yes, I agree that this is incorrect behavior.
All right. I think we're universal on that one. But that was the only other thing I saw, and basically issues popping in. Anybody else have topics you'd like to chat about today? Or we can talk more about the compression and decompressed layers. Or we can chat more about Blake 3.
I would love to hear at some point the registry concerns for transport compression, because I don't run a registry myself and don't don't know what I don't know. So
Ram doesn't want to answer this one. I feel like the best reason I can think of is that you'll start seeing uncompressed blobs showing up, and that can be a lot of storage.
In a world, if you charge user for storage, I mean, that's just back on the user. Yeah, I mean, I think that's kind of the biggest thing is you wouldn't want to store it multiple times. And so the registry would have to choose how and where to store it. And then, yeah, if you're only storing it in one way, then you're probably only going to want to serve it in one way. So you're not, recompressing it on the fly, because that would be expensive for some layers. So yeah, it's probably a matter of deduplicating the storage in an efficient way, or just
Yep.
not and passing on the cost.
If you do store it compressed, the next challenge is going to be if you start getting a range request.
Yep.
Because a range request in that means you're going to have to start doing some kind of on-the-fly decompression to find the point in there.
And then figuring out those pointers to say, okay, well, this blob is that compressed version, and
That's when you just return back what is it, a 4.0 or a 4.10 unsupported.
Makes me think I need another conformance testing I have to include in the next conformance suite. Push an uncompressed large blob, do a range request, see if it works.
Yeah, because I know currently, in order to check if the range request is even supported, they has to have the accept ranges header response, or accept ranges bytes. So technically, for that descriptor, you could respond. You could say don't return that header, and clients semantically are supposed to say, oh, I didn't get the accept range header back from this head request, therefore I can't range request this content.
From
Although
the
that does mean
HTTP
though that you have
specs,
to. What is it?
from
Sorry.
from the HTTP specs, yes. From the distribution specs, we're in some shaky ground there.
Hmm. Yeah, because right now I'm just storing that whether the registry just supports range as basically just like a global singleton per registry instance, per registry client instance, because I know it's not going to change, but I would just change that to basically like probably a concurrent hash map of descriptors of whether or not they support range in order to make that test. Saying it's doable, but it might just be annoying.
And it's definitely doable. It's just, do you want to decompress this thing that you've stored compressed and then recompress it so you're not blowing up the network? That's something that's going to throw a lot of people into a tizzy. Which means Rom's over there saying, yeah, that's why I'm not supporting this.
Yes.
Yeah, but I mean, it's not like we haven't. I mean, but I think there are a lot of benefits behind it. And so it's definitely worth exploring and doing, even if it does make it a little tough. to implement in some cases, there are still a lot of benefits behind it that are very, very valid and universal for a lot of different use cases. So yeah, I agree there's going to be some challenges on the implementation, but I still like the idea of doing it.
All right, so we got one no, bunch of yeses. It'll happen at some point here. And so if you do run a registry or you run some client tooling, it might be a good time to start looking at what it would take to start adding this.
Question I just thought of. So layer is stored uncompressed, and then the content negotiation goes through, and they decide upon, hey, all right, we're going to use Z standard for our compression algorithm. I think someone brought this up earlier. You also need to pass the parameters of that compression, right? Otherwise, you would, during your transport, you could compress with, say, level 12, but your client is uncompressing with level 10. Does that change the content at all, or does the content remain unchanged?
Is that a thing on Z standard? Because I know in gzip, you compress it with whatever level you compress it at, and the client decompressing just automatically attacks whatever is there.
It's able to detect what level it was compressed at.
All it needs to know is that it's gzip, and even that's, detectable, but the compression level comes through with the data that was compressed.
Yeah, I thought the decompression, everything that needed to decompress was sort of baked into the output file. But I think the parameters only matter on the compression side.
Gotcha. So client-wise, you wouldn't be able to specify how deep of a how strong of a compression you want. You could just specify algorithm type.
Yeah. And you would give the server options. You would say, look, I'm only looking for stuff that gzip and compressed or uncompressed.
Mm-hmm.
If that's all you want to support, and the server comes back and says, well, I was going to give you bzip, but since you don't support that, you're getting the uncompressed. All right. If there's nothing else, we can go ahead and break a little bit early. Or Saeed, did you have something else?
Yes, one thing. So serving uncompressed data on the fly, as a registry owner, we don't do that. Mostly because of we serve everything from a CDN. So
it's not that you don't serve it uncompressed, it's that you serve it with whatever the compression algorithm that the blob was pushed with.
exactly, yeah, we don't modify on the fly, or we don't decompress on the fly. So
This gets into
sorry, go ahead.
This gets into what CDN support on their side. Does a CDN support compression, transport compression on their side, which CDNs may do that.
That is true. Yes. Yeah, you can. That is true.
And this would be client tooling negotiating with the CDN saying, hey, I'm a client trying to pull this 10 gig blob. Can you compress it for me? And the CDN can come back and say, yeah, sure, here you go.
Yeah, but that's mostly transport compression, like HTTP gzip compression, not the actual, like, I don't think you want to do, I guess, blob uncompression. I don't. CDNs only do transport layer.
Yeah, and the idea here is that instead of trying to store it compressed, keep it a compressed descriptor, and then pass some other data in that descriptor that says, here's the uncompressed data, just give an uncompressed descriptor, push the blob uncompressed, and the compression would only happen at the time of transport, and potentially the registry would do it as part of their storage, and the registry might just pass all this through, so it doesn't have to do any decompression anywhere. But it's one of those things where, in reality, what's being passed around as an uncompressed blob is just being compressed transparently at each step of the process.
Gotcha.
And so you would tell the CDN, here's my uncompressed blob, but you might even push it to the CDN with transport level compression.
Yeah. Yeah.
But from the distribution spec API perspective, whatever was pushed is the canonical artifact. So if that's uncompressed, uncompressed is canonical, and no matter what, it has to be quote unquote at rest in an uncompressed format. When we talk about this thing, we're talking about it in the sense of uncompressed. It doesn't matter if there's some implementation detail that compresses it behind the scenes. When we talk about it and use it, it must be in an uncompressed format. When we do a range request, it's a range request over the uncompressed data.
Yes.
Even if that range request then applies transport level compression on top, that's totally sane, totally valid, but also totally transparent.
Yeah, to Brian's comment, how would a registry store it? I'm guessing a registry is still going to want to store it gzip, just knowing how many people are gzip compressing all the data around and not doing blob and not doing range request. And then that would mean they'd have to do some kind of decompress on the fly to potentially recompressing it again if they wanted to support a range request.
But to Brian's point in the chat, as long as a registry is willing to decompress at poll time, it can store it in whichever format it prefers. So if a registry is, say, totally concerned about storage and only storage, then a registry can store the blob in whichever format gives them the best compression ratio. And they could even determine that per blob. If they figure out some fancy algorithm to scan a blob of uncompressed content and decide which algorithm is going to get them the best ratio, they can store each blob with a different compression algorithm, and that's totally valid as long as they can then decompress it and return it in its uncompressed form again.
I could also see a registry looking at which blobs are most popular and storing those popular blobs multiple times, knowing that the one-offs where some client is going to take the Z standard is going to offset the little bit of extra overhead for storing it twice.
You'd have to then track the relationship between the uncompressed data format at rest and its compressed version format. Like there's no direct relationship because the SHAs are different. So you'd have to have some
Yeah.
sort of state stored on the registry somewhere that's tracking that. I mean, you could, same way that you do the link files with the hashes, you could technically make a link file that's named, with the file extension. And then the same way we were doing with the layout, name it with the file extension that points to the hash of the compressed version. So technically not too bad to add.
Yeah, the content storage name, the hash that you're going to put with this is always going to be whatever the original data is. In this case, what we're saying is the non-compressed data. And so it's always going to have that same hash, but it might just have a different extension.
And of course, a registry can also opt to do nothing here, or do something fancy like ZFS file system compression on their actual storage. So they get the benefits of compressed storage without having to worry about the cognitive and computational overhead of actually doing compression. Let the file system do it transparently. Move it to a different layer. Make your registry respond with, no, I don't support transport compression, sorry.
I feel like we effectively decompressed a very short agenda into a full meeting. Nobody? Nothing? Nada?
Delete
I left.
this.
I left on the inside.
And cried on the outside. All right. We're getting close to the top of the hour. Any last thoughts?
I'll circle back on diff IDs. Diff IDs are an expression of the need for the uncompressed content. because
feel like-
runtimes have to have a digest of that uncompressed content. So we had to put diff IDs in the spec. If we switch to uncompressed content, diff IDs hold less value. And arguably they hold less value in a content addressable storage anyways, but even less if the storage reflects what the client actually needs.
I really want to pull that out of the image config. I also want to pull out the whole history out of the image config and put that into the descriptors themselves. Once that's done, that means that we no longer have it's a unique config per image. I was trying to say content addressable, but the config is content addressable, but it's not unique per image. And that's going to cause some people to have ruffle feathers.
Yeah. Unlike uncompressed layers, that's a breaking change. But it's one I like. I'm in favor.
I want to go that direction, but there's going to be a lot of stuff that goes wrong when that happens. Might be a force of a V2 on the spec. All right. Last call. Going once. Going twice. So have a great rest of your week. Thanks for all the great discussion, and we'll circle back here next week and see what pops up on the agenda for that one. Thanks, everybody.
Thanks.
Thank you.